Welcome, everyone. How's everyone doing? What's new? Welcome to the third episode of SDK Unwind, where we kind of take a step back of all the complexities in the Polkadot SDK code base, and I really am aiming to ease people into getting started with developing blockchains that can connect to Polkadot, but also just maybe skilling up and people who are just curious to understand the intricacies of developing um, parachains, developing maybe tooling that interacts with parachains. There's a lot of stuff to unpack, and it can get intimidating. So this series is really meant to be for people that are just getting started, but as well as folks that are learning and might have things to share with other people getting started. My name, for those who don't know me yet, is Sacha Lansky, and I work on the developer relations team at Parity. And my passion is to demystify things, to make it easier for people entering our wonderful and I would say an ecosystem that is really pushing the boundaries of these Web3 technologies that we care about, that brings us here today. And well, my mission is to make these technologies more approachable for people that are maybe just getting started with understanding what they can do and stuff. So this is these first few episodes have been kind of just taking one angle into this mono repo, which is the Polkadot SDK. And there's no particular. I've gotten questions about whether there's like a continuity of episodes, whereby do I need to like listen to the previous episode to understand what's happening on this next one? The answer is not really. I really try to hone in on specific topics in each episode. I will say though that these past episodes have focused primarily on Frame, which is a opinionated way to write the logic of a blockchain that can connect to Polkadot. So we've been doing a couple episodes on Frame, really basic stuff. I've been sharing tips. I've been also keeping track of those tips, and I guess without further ado, I'll just go ahead and share my screen, because what I did for this episode is I've actually created a repository, and this repository has been the things that we've been tinkering with over the last few episodes. So I'm gonna just add that to the stage here. Yeah, so here it is. It's called SDK Unwind. You can find it right here in on my own private GitHub account, and pretty much if you've missed the previous episodes, again, like there's no continuity, but it came to my occurrence that well, it would be nice to maybe have a place for people to like refer back to things that we've done, and also a place for me to update and sort of iterate on certain things if that's the direction of where we want to take things. I want to emphasize that like this is for you guys. I'm here also to just propose ideas that I want to hone in on and tinker. But we're all here today live streaming. Like we those that are tuning in, you have access to the chat. You can ask questions, so use that, ask your questions. And actually, let me just share this link. Here we go. Yeah, you can find it on the github.com/Sacha-L, which is my GitHub handle, SDK Unwind. So there's just a couple things that we've done previously for those that are interested, but really I want to emphasize that there's no necessary continuity. I guess I will say that I foresee the series being maybe we can kind of hone in on things in batches, and because this is only episode 3, actually we've done a kickoff episode 0, so that's technically 4 episodes. Well, Um, we have been, like, sort of, my approach is demystifying things and showing tips about frame and building pallets. And yeah, that's pretty much it to kick things off. How's everyone doing? Where are you guys tuning in from? I'm here in the Berlin office. Um, I've got things ready for you guys. I'm pretty excited. Um, I've pretty much what I want to hone in on today is uh, like, kind of two main parts. The first being a higher level, more philosophical take on what the hell is Substrate and how does it fit in the grand scheme of the Polkadot SDK. Um, so I will maybe just pull up, this Polkadot SDK monorepo, what it is. For those that are just tuning in for the first time, welcome, all of you. Super stoked to have you uh, tune in with us today. But essentially, this Polkadot SDK is a mono repo. It's a huge Rust code base that contains all of the functionality to create custom blockchains, and blockchains that can be independent, can run using their own consensus logic and all that stuff, can run using their own validator sets if they want to. We typically refer to these blockchains as standalone substrate chains. Ooh, I just said Substrate. What's Substrate? Well, Substrate is that it's that it is an SDK within this SDK, so to speak. It's really an unopinionated way to create blockchains. And now you might be saying, well, why is that part of the Polkadot SDK? Well, because what's the power of Substrate is that it is then easy to adapt to become a blockchain that is secured by the Polkadot network. So we're in the world of app chains, right? Each chain has its own specific logic, and um, there is a lot of, what's the word I'm looking for? A lot of benefit. There's a lot of benefit for teams who have really great blockchain app chains ideas that want to deploy to the Polkadot network in order to benefit from its shared security, in order to not need to have your own validator set, et cetera, et cetera. Um, yes, like, no particular detour I want to make here, other than just for people maybe that are just tuning in. SDK Unwind really is focusing on this Polkadot SDK repo and all of the things that relate to it. So these first few episodes have been relating to the thing of Substrate, and specifically Frame, which is the library to help create the logic of an application-specific blockchain. Hopefully that makes sense. Sweet. We have people saying hi. Hi, Ayushi. Hi, Arnaud. Hey. How's it going? And Kaloyan, nice to see you here today. Kaloyan, I remember you tuning in, I think, in episode 1, and we had a lot of fun. Kind of just, I was sharing some patterns of frame development, and I remember you being very, very, very warm in the chats and helpful, and that was really nice. So again, like, that's also a call for anyone that's new here. Feel comfortable to ask questions and interrupt me, etc. So, this is a great. So Arnaud has made a remark here. Oh, I thought Polkadot SDK was a rebranding of Substrate. So that's not entirely correct. So as we can see, what like, I guess the question is, what happened? Why do we have the Polkadot SDK as this mono repo? And why is now Substrate just a part of it? So Polkadot SDK is not just a rebranding of Substrate. Substrate is still a Rust library for creating app-specific blockchains. And in fact, all it is that it now just lives in this mono repository. So as I was saying in the beginning, we can use Substrate to build standalone blockchains, and the power of Substrate is that then it can become Polkadot compatible. Now, why is it in this monorepo? There's a lot of good reasons why it's in this monorepo, specifically around like maintaining all of the Substrate code base, which really was being used a lot in the Polkadot code base. So the Polkadot code base essentially is a node implementation of the Polkadot relay chain, and so it became a pressing matter to actually bring these repositories together, which is the outcome of this mono repo. Yeah, hopefully that answers that thought. Thanks for saying that, because I think a lot of other people might be wondering the same thing. Um, cool. Yay. Okay, let's get to it. So what do I have for you guys today? Substrate and diagrams. That's kind of where I think for this episode, um, there's I find it very useful to visualize what we're talking about and what we're working on. In the last few episodes, we kind of went right into building a palette, which, by the way, you'll see when we get to doing that in the latter half of this episode. But it's true that then, what was nice also is it's just all Rust. We're just really focusing on creating the logic of the palette. A palette is just a Rust module that then can become the logic of an app specific chain. And we, contrary to like how the tutorials, for instance, on the docs website would kind of teach, we're really trying to do it from the ground up. So for instance, those that have maybe been around for a while, we have like the node template, and the node template is this. In fact, I could pull it up here. So right here, what we're looking at is the actual Polkadot SDK in my local environment. So this node template, for instance, if you go to the Substrate folder and I go to the bin and node template. So this node template is what a lot of the tutorials use to kind of start your blockchain in your local environment. So like we could compile this and then just start a chain. But what becomes quickly confusing is, what are all of these Rust crates that we're using? What's this node folder doing? A lot of question marks that the tendency has been to sort of say, ignore all of that and just focus on this one thing called pallets. And I personally find that might not lead to the most successful developer experience for those that are like new and trying to understand what the hell it is we're talking about. And although it is a place to continue learning from, I've wanted to really strip things down to, okay, what is this thing we're talking about when we say pallet? And instead of going right into, oh, you can add this to a blockchain that then you can run locally, we've actually been just working within the mock environment of we were kind of mocked a blockchain whereby we then write tests. So for instance, you can check it out here. This is what we did in the last episode. We basically have this mock environment, which really is the same thing as you would expect in like a production ready chain. Typically, what the node template presents is a chain that you can run locally, you can add validators to, etc. But it does present a lot of complexities that I think are not they're not conducive to really getting the basics and the foundations right. So here's a mock runtime, and we're just kind of writing tests and using like a more of an isolated environment rather than trying to put it into context that may open way too many question marks. So yes, this is sort of the approach here. We want to kind of do things from the ground up. And yeah, what are we looking at? Oh yeah, this is that we kind of just wrote a few tests for this super basic palette that we had, and it showcases the the it showcases the what's the word I'm looking for? It showcases the foundations of like frame and substrate essentially, without getting too distracted. Okay, cool. Um, we've got some people in the chat saying, "Yeah, great to see you here." Hey, Ayushi, great to see you. Really cool to see you in the chat. Renee, hi, also. And why should Polkadot Network not add two pallets to extend user base? EVM wallet pallet, EVM pallet. Cool, Rust Ninja. I'm gonna leave the question that you put in the YouTube chat just aside because we're gonna jump into some like kind of more basic stuff for this yes, like first few. I'd say like 15 minutes at least, and hopefully it brings people to asking questions and stuff. And okay, throughout this stream, like, and this series, I want to share tips always, right? Ooh, I forgot something. I forgot to mention something while we're kicking it off. I talked about kind of the nature of the stream. I talked about like things are sort of like not necessarily having continuity because the reason is I want people to just be able to tune in and learn something without needing to feel like they need to catch up on a lot. Um, Probably next episode, I will be inviting a core frame developer from Parity who's going to be going through a feature that is recently merged into Frame, and we actually might discover what this feature is in today's episode. Hopefully, leading up, sort of setting up some context for those that are curious in joining next week's stream as to why we might have this feature. So that's kind of just a plug for those that are wondering like what to expect with these episodes going forward. I really think that there'll be a lot of value in sort of isolating mini series within the the SDK Unwind series. So diving into more frame stuff, and then perhaps going into, I don't know, sub XT, like constructing calls that then you can interact with blockchains. Or perhaps we can do a whole series on more front end development stuff and actually building apps and stuff. So think of this as episode 3 today, just more frame substrate stuff, and in the future we'll be having kind of more isolated topics, in which case they could sort of follow up on each other. What are we looking at here right now? Does everyone know about this resource? For those that don't know about this resource, I think it's an incredibly great place to get an overview of all of the things we're actually building at Parity. So paritytech.github.io is basically a landing page that has all of the projects. So the main projects is Substrate, Polkadot, Cumulus, and Ink. Really, these first 3, as pointed out by I can't remember who in the chat pointed that out, but the question around it was Arnaud. Arnaud has mentioned the rebranding of Substrate is really just Polkadot SDK. Well, like if we could click into these, I'll show you immediately. Actually, these 3, Substrate, Polkadot, and Cumulus, are part of the same SDK. Like we need to start thinking that way. It's the same monorepo, and within this monorepo, we can use libraries for specific needs. Yes. So, for instance, if I click into the Substrate one, which we're going to check it out, well, you can see that it's actually part of the Substrate SDK altogether. So if I go here, then yeah, that's goes to master. And these are the Parity hosted Rust docs. These are also published on crates.io, but the I think that the difference is that some documentation is exposed on our locally or sorry on our publication of the different crates, as well as that the cadence at which they're updated is faster. Yeah, okay, so if I click into Polkadot, then I get into there. Again, it's the same mono repo. Cumulus, same thing. I'm still in the Polkadot SDK mono repo, but going straight into the Cumulus crate. If anyone wants, so we haven't really talked about Cumulus at all yet. That's kind of, I think, something that we can dive into in later episodes. But pretty much, pretty much Cumulus is just a set of libraries really that can equip your Substrate chain to be Polkadot ready, in a nutshell. That means ready to actually submit blocks to the Polkadot relay chain. In other words, it is a set of libraries that can turn a standalone Substrate chain into a parachain, into a app chain that can connect to Polkadot. Cool. So let's just dive into diagrams now. Any questions? Feel free to ask on the topics we've just covered. Yes. So I wanted to show you guys this new Substrate crate of just documentation. So this crate in of itself does not contain any code. It's just meant to be. Ooh, there's a typo there. Cool. Okay, one of the things I do on these series is I keep a scratch pad for the things that I find that I might want to address in a follow-up issue, or actually just make a PR to fix things. So this is something I can fix right now, like really easily. I won't do it right now, but I'll add it to my scratch pad. So actually, I keep the scratch pad here, and actually this is something I'm going to be publishing on the repo. The SDK Unwind repo. But yeah, that's just a typo. This is fun. This is fun. These streams are really meant to like just be fun. Okay. Typo on the Substrate crate. Small but minor fix that would be nice. Okay, so basically, yeah, this crate does not contain any code. It's just documentation. But this is really this is why I kind of mentioned in the beginning. It's kind of more philosophical start to this episode. Substrate approaches blockchain development with an acknowledgement of a few self-evident truths. Like so Substrate basically it approaches the whole approach of this code base really, and sort of the design and architecture of a Substrate chain falls onto like these two pillars, which is, society and technology evolves, and humans are fallible. This sets things up, by the way, for those who aren't really clear on why is it that in a lot of the documentation and the wiki we hear about this forkless runtime upgrade concept. And I mean, I'll leave you guys to kind of read this in your own here. I'll post it in the chats. Yeah, this link you can see here, but essentially, the pillars to address these two stated truths of the world, like, we are human and technology evolves. Well, so here it's kind of described as, in order to achieve this goal, Substrate embraces the following, right? The use of Rust, which is a modern and safe programming language which limits human error through various means, most notably memory safety. And Substrate is generic. It is generic, modular, and extensible by design. That's really just a bunch of words to say that it's built from the ground up to be extendable, to be composed of a lot of different logic, that it really is in the power of the developer using Substrate to use to sort of develop and create in a sort of boundless way. We don't want to put opinions on how to build blockchains. Um, the other thing is that lastly, the final blockchain system created with the above properties needs to be upgradable. So this really highlights the concept of the forkless runtime upgrades that I'm sure some of you guys have heard about. But it says in order to achieve this, Substrate is designed as a meta protocol, whereby the application logic of a blockchain is called so it's called the runtime, is actually just a WebAssembly blob that is stored on chain. So every Substrate blockchain has a storage item that is really just storing a WebAssembly blob that encapsulates the entire business logic of the chain. And the rest of the system is kind of separate to that. It's a client that executes this logic, that executes the runtime, aka that executes the WebAssembly blob. So let's jump into diagrams, right? I think that that sort of having a mental visualization or representation of what all of the things we just said right now, it can be really helpful. But yeah, there's a bunch more here. For example, the structure of the code base. So Substrate is a massive cargo workspace with hundreds of crates, which is true. Like, let's check it out. I mean, Substrate is just this folder in the mono repo, and really has a lot of stuff. At a high level, there's libraries that contain primitives such as doing arithmetic, doing arithmetic, and for instance, other languages have their own libraries to do arithmetic. Other blockchain or other smart contract languages, I meant to say, have their own means of doing arithmetic. Safe math is important when we are building systems that could introduce other errors. So this is sort of an entire library to do arithmetic in a Substrate chain. And there's a whole bunch of things, right? Like we might kind of jump from diagram to code base as we move along, but the other thing is, all of the code that pertains to the off-chain world of a node, right? A node is really just, remember, it's just a WASM runtime with a client that executes that logic. But yes, back to this. It's a bunch of crates. A bunch of crates. Okay, so yeah, this doc is very very useful for readers that want to just get to the point of what it is that this code base really is and what it allows you to do, and also how the philosophical design of it. So I'm really stoked to be sharing this because I don't think a lot of people have come across this resource, as it's pretty new. It's a pretty new resource that was initiated by one of the core developers at Parity, who also likes visualization and likes diagrams. I really like to be able to visualize things, and this helps a lot. So at a very basic level, right? We've got a Substrate blockchain that is just a client and a runtime. And then a bunch of libraries to build each of those respective entities, but also then a bunch of libraries to communicate between the two. So Substrate and diagrams, like at a very high level, we've got the client actually communicates through runtime APIs, and the client and the runtime, sorry, both of these entities communicate through a runtime APIs and host functions. This is just that you, like, some of you that might come across this terminology inside of the code base, and that's really all it means. So for instance, like the runtime, like for instance, when we write a pallet that a palette that stores some logic, that is actually creating like a s- a- that is making uh, what's the word I want to say, that's using some storage that is available to that runtime, and it needs to call into that storage, using a host function. So all of the storage stuff actually is all of the storage stuff in the runtime is some abstraction layer over it's basically the I/O of the runtime. And essentially, when we create a storage and storage a piece of storage, it's like I need to work on this terminology. When there's a piece of storage that's put into the chain, that is actually using a memory that is in the client. So we use host functions to sort of write there, and runtime APIs then are used from the client. So, for instance, if you're a validator and you need to check something that's in the runtime, well, we use a thing called the runtime API, which is like, for instance, a client. So that means like a validator wants to check the, I don't know, it could be, what's a common runtime API? Well, the the block, or the validity of a block. When we use a runtime API to actually call into the runtime and check what the state is there. Um, but like then there's this diagram that kind of expands even a little bit more. And thanks a lot, Kian, for putting this together, because it starts to make a little more sense. We've been kind of honing in onto frame and all these pallets, and then sort of this depicts sort of where, at a high, at a high level, like where they their sort of their utility in the context of a substrate node. Really, this is a substrate node. This whole diagram depicts a substrate node. There's a client and there's a runtime. And now this diagram kind of goes a little bit deeper, saying like the runtime really is sort of all this palette stuff we've been doing, where we have Rust modules that then can compile to WebAssembly and encapsulate the business logic of the chain. And the client really contains everything that's off chain, that's outside of the runtime. So that's maintaining the database. That's the networking side, i.e., like peers communicating with each other, and that's all the consensus stuff, really, that is also deeply anchored into networking. Um, so yeah, hopefully this is a cool little kind of intro to this episode. Yeah, if there's any questions, that would be real cool. Yeah, sweet. So yeah, little kind of philosophical context on the the architecture of a substrate node. And it's relevant because we're going to be kind of this whole the entire like premise of these series is to sort of unwind, demystify, whatever you want to call it, um, what it is we're doing when we're like building with the Polkadot SDK. And right now, we've really just been using one part of the Polkadot SDK, which pertains to this frame stuff, and the different pallets, right? Like literally, what it is that the stuff that we've already done. Again, I've shared it in this GitHub repo. We've created a super basic palette that allows you to accumulate a value that's in storage, and where we're just trying to show like basic patterns, but it can get a lot more complex. Like we've got pallets that handle the logic of, let's say, like, well, one thing actually we looked at last, we can do it again here, is the bounties, right? So we have a pallet that actually manages on-chain bounties that are funded by the treasury. And I mean, this palette is very extensive. There's a lot of code into it, but the basic patterns are sort of what we're trying to debunk here. So yeah, we really took it very simple. We have just one call that can accumulate this function. So I think we did it last episode or 2 episodes ago. But anyways, back to this. Well, that's just living in this world here. Like we're not really doing anything on the client side. We're also not really talking about this entire runtime API and host function side. Um, and one thing like we didn't talk about, which would be its whole episode, is like how can we communicate to this runtime via an RPC or via light clients. Well, there's several ways of doing that, and that that that's that's kind of outside of the Polkadot SDK. I mean, it's totally outside of the Polkadot SDK, but it could be a really interesting topic to cover. So that's relevant because we need to understand how to construct calls, and we need to understand how Substrate expects a call to be constructed, how the runtime expects a call to be constructed, and by extension, how Substrate does it, right? And how it works under the hood. So yeah, we're kind of doing things from the ground up in these first few episodes. And one thing I will say is that it's becoming easier and easier to build with Frame, and huge kudos to the Frame team, because there's been massive improvements over the last year, even over the last 2 years, even more, and that's really thanks to improving developer experience, in making it harder to make mistakes, and making it easier to just get going with writing a pallet, experimenting with what you can do with it, and deploying a pallet to a live chain, and things like that. So yes, living in this world, high-level diagrams of Substrate. Now, to extend it a little bit, okay, this is the same window. Ignore that. To extend it a little bit, oh, cool. Yeah, there's a comment here that's worth it. So it would be nice to see where an off-chain worker is in this diagram. So thanks for that comment. So essentially, all a off-chain worker is. So an off-chain worker is this concept in Substrate that says, we can have a pallet that takes information from the outside, and sort of uses that information, then writes it back to the on-chain runtime. So it's an off-chain. It's this concept off-chain worker. Actually, I'm going to pull up the docs. Off-chain worker. Let's do this. The off-chain worker is really just sort of like one use case could be an oracle, or it could be some off-chain data that is needed to do some compute on-chain. So if you do off-chain operations, you'll learn about it a bit more here. Oops. And then I also want to share the Rust docs. So learn, yeah. And then I also want to share so a super useful pattern that I've been trying to really instill is you've got these Rust docs, and if I go off-chain worker, then we can actually we can let's do a little detour here, because it pertains to this this architecture that I'm trying to paint in the context. That sort of the architecture diagrams and stuff really depict all of these crates that the Polkadot SDK is made of, and in particular Substrate is made of. So actually, we have this SC Offchain that is a crate to manage the sort of an off-chain worker implementation. And so off-chain workers can be used for for computation-heavy tasks that are not feasible for execution during regular block processing. It can either be tasks that no consensus is required for, or some form of consensus over the data can be built on-chain, for instance, via a challenge period, for incorrect computations, majority voting. So, like, this is a very dangerous thing to do if you don't know what you're doing, because to be bringing things on chain, um, with without sort of being absolutely sure that, first, that source of data is correct, and second, that source of data doesn't bloat the resources that you have in a block, because it's kind of abusing whatever call it has access to. So use them with care. This is just kind of to showcase or to show that, so at a very high level, we got this crate that then an off-chain, like an off-chain worker, has its database, with some storage, and now back to the diagram. Okay, actually, we did it like this. Okay, I'm gonna just go back to where we were before. 1 second. And in the diagram, to now that we have a little more context, um, where's my diagram? Oh yeah, there. Cool. In the diagram, all it is, Kazunobu, is it's a host function, right? Because all an off-chain worker is some storage that the runtime has access to. So think about it like that. All an off-chain worker it's a bunch of host functions, and so the SC off-chain crate is the Substrate client, um, like they're crates that are on the client side, and they provide that functionality, that creates storage off chain, and then a pallet can then or pallet writes to it and then can also read from it. Cool. Hopefully that answered that comment. Thanks for interacting and stopping me. Uh, so, because again, like, I guess just looking at this diagram, like, without questions, could feel maybe a little dry. Hopefully that added to it. Cool. Where were we? Oh yeah, off-chain operations. Did I? Oh yeah. There was one thing I wanted to share in the context of off-chain. So there's this example palette example off-chain worker. So if anyone wants to learn anything, like anything about off-chain workers in context, check out this example palette that literally goes through it. Cool. Yeah, it's inside the client. Exactly. Yeah, this palette actually gives examples, and kind of highlights the dangers of using an off-chain worker. Again, you don't want to be using anything that can write to your on-chain state without making sure that it's safe. And safety implies things like, well, the truth, right? Like, is this data valid? If it's an oracle, like, has there been verification checks and sort of sufficient decentralization of that source of truth in order for it to be a valid piece of data to put on chain? But then also you want to be super careful as to not allowing any type of data to do any nasty things to your blockchain, and enter and through your pallet. But yes, I highly recommend those that are interested in off-chain workers to look at this examples palette. That's kind of a nice little piece to like go into. I mean, I want to use this fact that we just looked at an example palette to say that when we really started off with the basics, we actually went right into the examples folder, and so you can see this is a big tip here that I gave before, but there's an examples folder within the frame directory that has a bunch of useful pallet. Oh, so they're just pallets that are exemplifying some useful features in frame. And yeah, you can see the Offchain worker lives right there. Cool. All right. All right. All right. So where were we? Oh yeah, dupe. Oh, cool. Okay, a little bit more diagram stuff. We've 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 like we're going a little deep here on the diagram stuff, but I think it's really worth um me sharing additional resources if I can here. And so one of these awesome resources was actually, do we have anyone tuning in who actually went through the Polkadot Blockchain Academy? Um, anyone in the chat that's watching that's from the academy? I was at the first Blockchain Academy. I was helping as a teaching assistant and like student support person when we kicked it off in Cambridge. The Polkadot Blockchain Academy is this very intensive 4-week long course that dives into all things Polkadot, Substrate, etc. But that's not sort of what I wanted to highlight here. It's more that they've open sourced all of the resources that are being taught at the in-person. It's an in-person, intensive course, but so the all of the slides are now open source, so you can see, you can learn a lot by going through this link. But in the context of today, Substrate and diagrams, I wanted to share with you a little more about the diagrams and how to think about it, right? So we've got, the runtime that says update me, i.e., so speaking to the client, and then the client then calling into the runtime. So a little bit more kind of color to what we just went over. Substrate architecture, right? It's really like there's all the client stuff, and then there's all the runtime stuff, and the runtime is just this WASM blob. And at even a higher level, then you just have a WASM executor that really can be considered as a client. More diagrams here. Okay, that's just a little. Okay, this is then this will be, if you're a diehard runtime engineer, you will have this like on your wall, right? Like I have this painted in my bedroom. Thanks, Kian and Sean for putting this together. It's a great. We should make posters of this. Wouldn't that be cool? So this kind of like gives even more detail around what a substrate node is. We've got all of the client stuff, and then all of the runtime stuff. Yeah, and the client is the database, right? Like when when we write a pallet that like makes some storage, well, the storage itself is actually persisted from the different nodes that are connected to the network that have the storage laid out on the client side. And yeah, I think that kind of closes it for this kind of first part, whereby what's important is the runtime stuff is just this WASM blob. Cool. And how does it relate to crates and stuff? We kind of looked over that. Again, if there's questions, please ask. But going back into the repo, we've got essentially, all these pallets that compile to WebAssembly. If you've ever noticed this piece of code, that is, actually, let's go into our own one. We make sure this pallet uses no STD for compiling to WASM, right? So we've got this kind of feature configuration thing going where there are libraries where we can use a standard library, that sort of there are crates that we use that can use a standard library, and but if they're not present, well, we will use the no STD library, i.e. we compile these pallets to WebAssembly. Hopefully that makes sense. Cool. So what are we gonna do today? I wanted to okay, so in the spirit of kind of trying to present things differently, um, first of all, I want to present this wonderful coconut drink that I'm drinking, and I'm gonna take a sip of it. Um, yeah, but essentially, like what I want to dive into right now is how you can organize your palette code. Um, and first of all, like the where I'm coming from is that there are patterns that you can see in the Polkadot SDK that is commonly used, but those aren't necessarily like the best way to do things. You know, those aren't or how to say, like, that's not the only way to do it, right? And you might feel a little more empowered by kind of what we're gonna go into today. Yeah, cool. Mm, multi-mod palettes. Okay. But the very first piece is just to check it out. Like, what are common ways to um, organize a palette code base? So that's kind of what we're gonna do right now. We're gonna check out how um, the a lot of palettes are actually already designed, like broken up. Like how a single palette is um, uh, organized, really. This is about sort of tips around organizing your workspace, and I think it's worthwhile diving a little into what some common practices are and what you might expect. So yeah, parity, Polkadot SDK, and let's check. Let's go to the bounties palette. Okay, so the bounties palette, it's a Rust crate that yeah, just click here. So in the bounties palette, I chose this palette because it was written originally, like I think about 2 years ago, and it shows a very common pattern of um, organizing your Rust crate. Like, really, all a palette is the Rust crate, right? So let's I mean, you'll hear me use those interchangeably. But what I want to show you guys is this bounties palette. As you would expect, most of them have like this lib.rs file that contains all of the code that pertains to this palette. And that includes any helper functions, that includes all the callable functions and any custom types. And then you have this test.rs file that includes the mock runtime as well as all the tests. So here we can see the mock runtime. It's all this stuff here. Again, this is like mocking all of the dependencies that this palette requires in order to run tests unit tests that pertain to this pallet's logic. Um, but the point here is that it's all in this test folder. Kind of like, that's cool. That's totally great, right? Like, if you want to just if you prefer to have it all in one folder. Okay, weights. We've talked about weights, but every palette that goes to production will have a weights.rs file and a benchmarking.rs file. But that's just kind of one way of doing it, right? Now, if we go to let's see. I think the lottery palette will probably have a similar structure, because it was also written around that time, and that was just kind of like what was done, right? So you can see there's the RS file, tests, etc. Same kind of pattern. Um, but let's find a palette that is slightly newer, that has been written like not too long ago. Okay, so NFTs is a masterpiece. NFTs is really a masterpiece because it really stretches the way just to use Rust as modules to write your palette. Um, oh yeah, so I have a shell palette, super basic, but no multi-crate palette. We're gonna be working on the multi-crate palette today, Alno. So yeah, brace yourself. And if you want to get a head start, try to do it yourself, right? So what we're trying to get, well, I'm jumping ahead here, Alno, actually, but because you asked this question, this comment is directed to you, because because I feel like you deserve the transparency. What we're gonna do is actually every pallet code is not a lib.rs file; it's its own module, and what that would look like. All right, so we there's instances where you're writing your own pallets, and there's a lot of them, and you don't necessarily need to make your pallet its own crate. You can have a crate of multiple pallets that include modules as your pallet, and that's kind of what that was a spoiler. I just spoiled it all for you guys. But for those that know me, I like to kind of take things slowly so that we have the context and we generate questions as we go. So that's what we're doing right now. We're looking at examples of how you could organize your palette code base. And the NFTs palette is a masterpiece. That's what I said last. Yes, it is a masterpiece. Why is it a masterpiece? I personally think it is a really, really great example of how you can very elegantly organize a very complex code base into easier to navigate bits and pieces, but also it is an elegant solution to not only for readability but also for reusability. So let's kind of dive into it. What do we have? So the author of this palette, there's a lib.rs file, and we have all of the core palette structure. So the reminder, core palette structure is there will always be a configuration trait. Every palette needs a configuration trait, and all of the sort of, and then this a palette macro. But in this case, the palette also contains a bunch of storage items. It also then contains a bunch of callable functions. So, oh yeah, there's events too, etc. This is the core functionality of this palette. So this call block here contains all of the callable functions. But if I scroll all the way down, that's probably where it ends. I think that really, and this is a very hefty palette, by the way. Yeah, so if I scroll all the way down, all you can see is the end of that call block. Now, you'll notice if, like, for example, if I go to the bounties palette or this lottery palette, it probably has more code after the call block as like helper functions. Actually, this is exactly. So if I go here, well, there's a bunch of these helper functions, right? So like account ID, i.e., like I want to just get the account ID of a lottery pot. This is in the context of a lottery pot, but the point is that within this lib.rs file, the author of this palette really kind of just was comfortable using a single large Rust file to put everything in there, including the helper. The helper functions really are functions that are either privately or publicly available. In this case, these functions are privately available to this palette. So now going back here, I was just depicting that the author of this palette actually doesn't have the helper functions within this lib.rs file. They've actually put them into their own module. So common functions actually contains all of that info, all of the functions that then are used within the palette. So this kind of like this ethos of modularity, of kind of reusing code, or at least giving the options to make it easier to reuse code. And I really want to emphasize that it's completely up to your own decision, but this is probably a really neat way to organize a complex palette, and the things that and kind of like putting out your own function, like some common functions into its own module. So then if I look at if I do like common functions, I can see that we imported this mod of common functions, and then use them, then use them as like we want it. So like, I don't know, what's a common function we can check? Set next collection ID. And there you go. So then we can just call it using self set next collection ID, which is just now important to scope because it's in its own module. And it's a really neat way, I guess, to reuse code too, right? Because then actually, if this is public, then we can probably then have other crates that could use this, just as a sort of an idea presenting the utility of splitting things up like this. There's also all of this impl non-fungibles. These are implementations of traits that this palette uses and relies on. Some pallets actually will just have that in the lib.rs file. In this case, it's in its own thing. So it's very elegant just on that level. Now, even more, right? So this palette is actually sort of, I think, like I'm biased because I've worked on some documentation on this palette, but hear me out, right? The author went ahead and actually created all of the features that this palette uses, i.e. in this lib.rs file, there's certain functionality that have been then abstracted into their own features, which is encapsulated by this features module with all of the modules per feature modules, right? So this module contains helper functions for the approval logic implemented in the NFTs palette, and more information about that, etc. So what are we looking at here is just it's kind of like pushing the boundaries of ways that you could organize really complex palette logic. Well, let's check it out. So I don't know, like by cell, for instance, is all of the functionality. Yeah. Yes. That's like so true, right? Like if those that like have a little more experience in like palette development, probably will even more be like, what Sasha's saying is so true. Like, dude, I've seen palettes that are just illegible. Like it's true. Like sometimes when it's just like all in one file, it's really hard to read too, right? So yeah. Cheers for that comment. Oh. Is that really the most conducive way to structure Pollet? I'm lost. So please let me know where you're lost. That would help me more. If you can reformulate your question as like what you mean. We're going over different ways of structuring your palette, and I wanted to present you with what you might find as you're going through different code bases that have palettes. So we haven't really gone to the point of like what I'm saying is like good practice, best practice. Right now, coincidentally, I am saying that this is a really neat way to organize your palette logic. But yes, if you have a specific question as to like where you're lost, please just interrupt. Yeah, where was I? Yeah, okay, cool. But so here, the author realized that there's a lot of feature specific common functions that might be reused in different places, and they've actually encapsulated that into their own module per feature. So we're in this features folder, and these are all the features that then are reused inside of the core lib.rs folder file that encapsulates the palette logic. Cool. That's a lot of talking. Yeah. Oh yeah. Okay. Well, actually, when we let's just. I got to this NFTs maybe a little too preemptively. I wanted maybe to show a different way to do things. That's so just for those that might feel a little overwhelmed about what I just showed. The NFTs palette is probably like I wouldn't I wouldn't say the most complex, but it's probably got like the single palette that has the most functionality packed into it. And that's why the author really went into creating these different mod only features. to then reuse and to and probably also to just be a neat way to keep building on that functionality. But that's kind of maybe that's maybe a little bit of a unique example that you won't. I personally haven't seen it in other palettes, but I did want to point it out as like a very very neat way to organize things. Let's look at like I don't know offenses. What does offenses have? Okay, no, same kind of pattern. What else? Reno. I'm trying to see. I know. Okay, the broker palette probably yes. Broker palette or the glutton palette is that? No. Yeah. Oh yeah. No. Okay. Wait. Patience. Oh, core fellowship. Maybe that probably that's a recent one. Yeah. No, because there's some palettes that there's more palettes that kind of show a more simplified version of the NFTs palette that just have helper functions in its own module. And let me take a guess. I think that we have one right here. Broker. Yes. Okay, cool. So yeah, the broker palette adapts a similar pattern where every palette has like trade implementations. Every palette has different types. So you can neatly organize your palette code with just putting all of the stuff that's not relevant or sorry, all of the stuff that this core lib.rs um, palette module, i.e. the core functionality of your palette lives, everything that doesn't need to be inside of this palette attribute macro can live in its own modules. So in this instance, we're looking at the broker palette. Who knows what the broker palette is? I was hoping that there were some docs here, but I can tell you what I know about the broker palette. It's just a way to kind of the 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 whole narrative of Polkadot is moving into this core time sale model whereby we need a palette um, to broker that resource that the relay chain provides, which is called core time. That's what it does at a high level. So we need a palette to manage that that buy and sell, and it's not buy and sell; it's really leasing of this resource. And so that's what the broker palette does. So it's a little more complicated too, and it has as what I'm just trying to depict here is it's got its own adapt price module that says, okay, these are traits and types for all adapt price stuff. And then, we can expect to find an adapt price inside of the lib.rs file. And yes, indeed, the type in the configuration trait that the price adapter is actually the specified as the type that was created in this own module. I'm seeing some activity in the chat. Yeah, why so Vishal, so why does Rust act as a resistance to me to become a Polkadot dev? I tried harder and harder. It didn't go well. Please suggest how I can approach this milestone. So I I feel bad. I don't know if you've tuned into the other episodes, but here I'm presenting things in a perhaps little bit overwhelming way, but it's really to set the scene for some more live coding stuff we're gonna do, and in the live coding stuff we're doing, like you just need to know basic Rust, and what I'm trying to uh, uh, um, what I'm really trying to what's the word? I want it to be apparent that it's about learning patterns. It's about like Rust isn't really shouldn't really be a barrier. Substrate can be overwhelming, and we need to learn patterns. We need to be familiar with sort of the do's and don'ts, the macros that are involved, and then at the end of the day, it's just like you're writing Rust code No different than completing a basic Rust 101 course or whatever. But you're not alone, Vishal. You're not alone. A lot of people feel that Rust is a barrier. Um, and my suggestion is, learn basic Rust. Know how to know sort of the basic core principles of the Rust programming language, and from there, uh, try to approach learning about palette development a little bit from the ground up. So that's kind of what we've been doing over the last a couple episodes. Cool. Another question. Is there an equivalent to the payment palette found in the ORML library in Frame? I'm not sure, actually. If you have a link to it, maybe share in the chat about this ORML palette you're talking about. I'm not sure, but probably. I'm not sure what that palette does, and yeah, so please share. Um, yeah, yeah, like totally. Thanks, Matthew, for adding this insight. Rustlings is a really, really great way to start with Rust. Um, and that is what like my number one recommendation. If you feel that Rust is a barrier, just know the basic stuff. And also, other tip is, don't get overwhelmed by all of this complex stuff. Try to do something very basic. Actually, that's a great segue to what we're doing today. So yeah, we looked at all this stuff, different ways to organize Pallet code, and we're going to jump right into this. Cool. Anyone listening to tunes? I like to listen to tunes, and I highly recommend it. It's kind of like a fun way, even if you're not like watching what we're doing right now. You can just chime in. Yes, yeah. So what time is it now? Let's see. Cool. I think for the next like 40 minutes, we can build on this um this we're gonna build two pallets, very simple pallets, and we're gonna showcase this a novel, and I want to introduce a different way of thinking about building your pallet logic. And we will then bring it into building our own mock runtime. And then if we have time, maybe write a test. We'll see how far we get. And so yeah, hopefully. Cool. Actually, thank you, Matthew, for this comment. So Matthew says, I love Rust, but I find the heavy use of macros and substrate sometimes hard to navigate. Very well said. Like again, like this whole, like, I want people to feel like comfortable, and Matthew's comment here really is tapping into like a feeling that a lot of people get when they're starting with Substrate, is that the overwhelming use of macros. So thanks, Matthew, for pointing that out, because a lot of people that feel that aren't alone. Like Matthew probably has a lot of Rust experience and is saying that, so that says something. And so we didn't go into like all of the macros in Frame so far. We really just looked at basic stuff, because our focus has been just like on the building a a frame palette. But what we did share in previous episodes is the like looking at the documentation of all of these the frame macros. So I'm going to share that right now. So if I go, I know it's like saved in my browser. So all of the attribute macros are here. And why do we use macros? Also, we need a minimal amount of like boilerplate for things like, when I declare a storage item, it's actually like, let's go back to this diagram. Declaring a storage item, there's a lot of stuff happening in the back. Frame is an opinionated way to use this very generic architecture of just having a runtime and a client. But declaring a storage item really means creating an SPIO, so using the Substrate primitives libraries to create some instance in the database that's in the client level, and it also does a lot of other stuff, such as like an opinionated way to um, uh, uh, um, basically encode the key of that storage, i.e., the way to find whatever that value is inside of this large Patricia Merkle tree. Um, and so there's macros that help you do all that stuff, and that's why they're there. They're there to help you. Um, and the thing I will say is that at Parity, we really are trying to, you know, have macros like do the basic stuff, like the stuff that's kind of really hard to do without using macros, i.e., like a lot of extra code to write, but empower developers to really just write Rust code inside of those inside of like any code that uses a macro, and that means like not trying to force developers to like learn a new EDSL of sorts and really trying to use macros. So this really just trying to use like pure Rust. But I want to share this with you, Matthew. Maybe that's helpful. So this kind of goes through all of the frame macros. There's other macros, like another one is construct runtime. Like that's a very mystical macro, and I think we're trying to improve it. But essentially, construct runtime is this macro that says, okay, so we have all these Rust modules that are pallets. They have their own like storage. They have their own events. They have all this stuff. Now we need to basically squash them all together and create a runtime, a WASM binary of all of those Rust modules. So construct runtime is one you'll see a lot, and again, hopefully, like looking at documentation helps a little more demystify those things. I also did an episode literally called demystifying macros or something like that with one of our core engineers. So that's also a good resource to check out. I think it's here. Look, I can check it out. But yes, macros have a tendency to introduce a little confusion, really. Let's see, like YouTube. Let's see, YouTube. Demystifying macros is a great resource. Macros, Polkadot. If I do macros, Polkadot should come up. Yeah, this one right here with our amazing engineer Sam. And literally, like, if you are a Rust dev, like, please, those that are watching, don't be like those that are watching that are like kind of really new to Rust. Please don't like see this as super overwhelming. Like, this is me just sharing for those that are a little more advanced and want to learn how macros work inside of Substrate and Frame. This is an excellent resource to do that. So I'm going to share this link to the video, and in this video we really go into how the current macro pattern works and how it's being improved, and all of the things that pertain to macros in Substrate. So here's the link to that video. Yeah, cool. Where was I? Yeah, Okay, back to this. So, oh yeah, like tips that I'd shared before. I have Rust Analyzer going on in the back, so that makes it really nice. This workspace is pretty small, so just going through it here, it's a small workspace here. And yeah, we're gonna add this multi-pallet crate. So one tip is this Rust format.toml. As you're writing code, it's really nice to kind of like every now and then run cargo. I don't. Maybe that's better for you guys. It's bigger. Cargo format. Oh, we use the nightly. Yeah. So this is great. So what you can see is here, I just did I just did cargo format, but we actually in this Rust format.toml file, we actually use a lot of nightly features of the of cargo format. And so it's and by the way, I just copy pasted this from the Polkadot SDK because that's the common, and it's also in our guidelines. So yeah, I highly recommend that you just copy this .rust format .toml into all of your Substrate projects, like hacking, like whatever it is, like as you're learning. Because for instance, ignore this multi-pallet crate thing for now, guys. But in the shell palette, like I don't know if I'm writing some documentation comments or whatever, and it's like this looking. Well, if I run cargo nightly format, then it'll fix it for me, right? It'll make sure that the line wrapping is respected. So that's just like something I wanted to share with you guys. Have this first format and run the formatting tool every now and then. Cool. Yes. So let's make a crate, right? Let's go ahead and make this multi-pallet crate. And what that means is literally, okay, so what I've done is go ahead and you create a folder in this workspace, and it has a cargo.toml file that is necessary for this to be a Rust package, and I called it multi-pallet crate, and it's just a demo of the material we're going to cover in this episode. Now, one thing that we did in the last episode, we showed how easy it is to just use crates.io to import pallets, and so I've kept that here. But one thing we didn't do is actually demonstrate that the need for this features, right? Where the default features is STD, and we need to specify the dependencies that have STD. So that's an important piece to understand this kind of concept of compiling to WebAssembly. Like that's why we kind of started with this architecture stuff. Why do we compile to WebAssembly? Because every pallet must be is every pallet then becomes a wasm blob, which is your runtime. But without digressing, the important part is, so now, okay, so we've created this multi-pallet crate folder, cargo.toml, and now we're going to create our source folder with the lib.rs part. And we've got this at the top, right? It's a conditional sort of if the feature is not STD, then compile to WebAssembly. We've briefly talked about that, but you can see that if you go to super basic pallet at the top, every pallet will have this. Okay, gonna lay out the next few steps here. Is we are gonna take we're gonna take this dummy example that we have here. So super basic palette is really just an example. We're not doing anything. We're just trying to get the patterns right. So I'm gonna just clear this if it's kind of in the way here. And so it's got just a simple storage value item that stores some balance and great and accumulates dummy. Cool. So we're gonna actually take that and put it in this new multi-pallet crate, because that's gonna be one of the pallets that we're gonna put in. So let's do that and see. Oh wait. I didn't at least talk about one important thing, is that once you have this multi-pallet crate, and you've named it multi-pallet crate or whatever it is you want to name it, make sure that you add it to your workspace. So for instance, now it's not in my workspace, and you can actually tell because I can just write whatever, and it's not going to be picked up. So I can look, I can do this. Oop. And we all know that the minimum functionality for a pallet is to have a config trait. I have Rust Analyzer in the back. It's not yelling. So why isn't it not yelling? Because it's not being picked up by the workspace. So I'm going to go ahead and do that. What do we call it? Multi-pallet crate. And yeah, one of the things oh, that's not it. Cargo. One of the things that came up in the last episode is like, okay, now let's see. REST analyzer. Ooh, what's it saying? Let's try to build that. Well, we're in the business. We're in the business of making the Rust compiler happy, aren't we? Right? So now I'm gonna just try to cargo check and prove to you guys that it's not happy. What did we call it? We called it multi-pallet crate. It's just a crate for now, actually. It's just, sorry, yeah. So the Rust compiler is not happy. Rust analyzer, for some reason, is probably just a whatever, missed the bus. It's still on the beach hanging out. It hasn't really realized. And sometimes you'll notice that, by the way, when I use Rust analyzer, it does weird things. Just ignore it. But I know for a fact that this does not compile because, well, there you go. It says pub mod pallet unresolved import. It's bugging out. And this error could be more informative, but right now it's not. But if I go back here, I think this should compile. Yeah, so that compiles. That's kind of just showing you. So what do we do here? All we did right now, we have this lib.rs file. But now let's go ahead and take this. So this is a shell palette. This hopefully is useful for anyone that's kind of starting, where you could start with a template palette, which is a typical way of getting started with Substrate. There's a template palette, it does one thing, it kind of sets a value to storage, I don't know what. But I think there's a neat thing about using a very bare bones palette and then starting there and then building, and not kind of starting somewhere where then there's a tendency to just like want to just follow what's already a pattern that's presented there, and that might that might work for you, but it also might make you kind of skip a lot of pieces of understanding how building a palette really works. So we're gonna keep it like this, and we're gonna actually I'm gonna make a new I'm going to make a new module. And I'm going to delete all of this, except for the very top, because we're still going to need it. And I'm going to make a new module called dummy pallet, dummy pallet.rs. And I'm going to take what we have in the shell palette. It's just there. Boop, zoop. And I'm going to put in this dummy pallet.rs. So there we go. We have this dummy.pallet.rs. But notice it's also like this. Actually, it probably won't compile. It will, yeah, it'll compile because it's all kind of correct. But there's nothing here, and that's because I need to then I need to specify that we have this module, right? Cool. Dummy.pallet.rs. Then it's being picked up, and okay, that worked. So now we've got a lib.rs file with dummy.pallet.rs, which does nothing. And let's just add a little bit more functionality to it. Like, for example, just take a callable function that we had from the super basic palette. Yeah, so let's do that. So this callable function, again, it's in the basic example palette inside of the frame repo. And yeah, let's just take all of this, because then it might be useful when we go ahead and write tests. Okay, and then so I hope you see where I'm going here. Like, we've got now this is a pattern you don't really see very much, but it's a neat way to think about pallets as just modules. Okay, so I've done that. Now that's not going to compile. Yeah, why do you think it's not going to compile? Does anyone know why this won't compile? So I've just added a call block from our super basic palette. that has this accumulate dummy and kill dummy functionality, but it won't compile. And why is that? Well, if anyone is courageous enough to answer, I'm gonna give it another second or two. While we do that, let's see what the compiler tells us. Aha. Well, okay. So the first error it's telling us is that it requires a wait, and we've we since we just copied from the super basic palette that's using this really cool feature in Rust called dev mode, we actually then we forgot to actually put dev mode in into the attribute macro. I mean, yeah. So if we add dev mode, we looked at what dev mode is in our last episode. It's essentially a way that is easier to hack on a pallet without needing to worry about things that you will need when you're when you're ready to go to production, right? So we talked about a bunch in the last episode, but feel free to check it out if you want to learn more about dev mode. There's also great docs about it. Okay, but this is what I was hoping to get to. So I was hoping to get to this error, why it won't compile. Well, because we don't have a a type for balance. And now maybe this is a fun little piece where we can yeah. Okay. So why don't we put our balance type at the top and do. So like um uh, it's just a U128. Oh, and it's not an associated type because let's just look back to what we copied from. We actually had the balances palette like tightly coupled to it, right? So that's just yeah. So we have this balances palette, but right now let's just ignore that and just do it our way. Let's just say that balance is just balance, and it's not. So what we had what this other palette was doing is that it's part. You see, it says T semicolon semicolon balance. Well, that's because in what we copied it from, it was actually a it the generic T of the palette was bound by the balances palette, which this is this code here, right? Config, and then that's why we were able to just say like T semicolon semicolon balance because it's taking the balance type from the balances palette. But in this case, we're just trying to like get something quick and dirty done. Let's keep going. So balance is a U128. Cool. We can even say that. The balance type for palette. Okay. And let's see. Let's keep going, finding the compiler. Okay, so then we haven't declared this storage value. Okay. So let's go back here and see what we had done for that storage value. Okay, it was a simple. I'm just gonna copy that over. Dupe. And I like to put the storage values pretty much right after the configuration trait, because the storage of a palette is really telling about like what it is this palette does. Like the storage is kind of everything. That's another thing you should have like written on your wall after having this substrate diagram architecture is storage is everything. And in these episodes, we don't go too deeply as to the implications of what that really means, but just bear that in mind. Okay, so and then it's just make sure that this is happy too. We got the type balance, it's there, yay. And we have a storage item. Cool. So all this does is let's see now. Yeah, that compiles. Just to show you, boom. So we have one pallet here. And now what if we wanted to add another pallet? So let's go ahead and do that. The new file. So the idea that I had for this is, imagine you have a pallet, because we've been in like this dummy world for a while now. So imagine if you had a pallet that wanted to store a list of members, and that that this pallet then manages those members. There's actually an entire palette that does this, but for the sake of like the simplicity of showcasing how you might organize stuff, um, let's just keep it super simple. It's a palette that exposes a callable function that anyone can call and add them to a list of members. And hopefully we'll discover a few things as we do that. Membership. Okay, cool. So we always need to do make sure it compiles to WASM. And let's put in this shell palette. Ooh, I needed to change something about it. What was it now? No, it was all good. Oh, it was about the palette, but that was the other one. So let's take the shell palette, membership, boom. And we then can start adding some functionality. Yay. So we want so this palette is a very, very basic palette. Maybe we can like keep building on it in future episodes. But essentially, we want to create some storage. So always we're using this palette macro and the storage attribute, and then we want this to it's a storage item called members. We're just going to call it that. And storage value. So we're using the storage value frame feature, which allows us to store one value in storage. And this is going to be a vector. So we're just going to say vec of account ID. So we want to use an account ID. And I put T semicolon here, but we're going to figure out that might not work. And it's a vec of a tuple, really, because it's an account ID, and we can imagine it's like also your membership number, also like, and probably just some bytes, and let's just put 1 byte that represents, I don't know, an emoji or something, like an ASCII value. So it's a vector of this tuple, and we then want to one more thing in the syntax is actually, I think I could just leave it like that. I think I could just leave it like that. Can I just leave it like that? Yeah, super cool. Okay, T account ID, that actually worked. So, but typically, so you'd also see the syntax where if we wanted to use something from the configuration trait, we would do something like T over config. But in this case, it's working. Yeah, yes. Okay, so I'm a little prepared now to showcase bounded vec, but first I'm going to show you guys that things aren't going to work out here. So Kazunobu says bounded vec is what we need. Previous episode. Let's dive a little deeper here into that. Okay, so I'm gonna. Oh, first of all, Actually, I hadn't thought that there's like, even if this was incorrect, I wouldn't be able to pick it up through Rust Analyzer because it's not in the lib.rs create file. Okay, so let me add that. So I want to do pub. I'm going to add this membership.rs palette here. And so now it's gonna start maybe yelling at me and saying things. Yes. Okay, so this members is using just a vector, and that's really not a pattern that you want to be doing inside a frame. What we looked at when we looked at dev mode in the last episode, we saw that dev mode alleviates a lot of stuff that you might want to omit, or you might not want to you can kind of ignore if you just kind of want to be hacking away at a palette. So if I add dev mode to this, it'll take away this error. I'm just going to leave it in there for a little bit, but then we're going to go back and fix this. And essentially we want then, so you see that should work. Let me try to cargo check this entire crate. Cool, that works. And we're just going to do the call block real quick. So call is, we're using this pallet macro. This pallet macro does wonders. If you have Rust Analyzer going in the back, you can click into it here. And that's basically the resource I shared with Matthew in the chat, where you have all of the documentation of the different attributes that you can pass in using this macro. So this is just me having clicked into there. You can ignore it, but yes. So yeah, why did I say that? Is because we have then this call attribute we're going to use, and all of that is it's an implementation block that that is not just an so it's annotated by call, but for Rust it's really just an implementation block that implements all of this functionality on top of this struct, this pallet struct. This is where the macro magic becomes kind of interesting, because really all a pallet is, it's a struct that then everything else that happens within the pallet code are just functions on top of that struct. So your callable function is really just a pallet semicolon, and like, well, let's just write this and then I can kind of go into it a little bit more. So we're gonna go config. So this is generic over T, and now we have our and it's an implementation of pallet. That makes sense, hopefully. We've got the struct pallet, and we've got the implementation of pallet. So this is the impl block. And then we can write our function. The fact that we are now in dev mode means that it's not going to yell at us, but when we remove dev mode, we will. Okay, so I'm gonna sorry, brain. When we remove dev mode, we might find a lot of things that will happen. If anyone wants to share in the chat what those things could be, please shoot. It would be cool to see anyone who might have some experience to share. So I'm gonna add this function that adds a member to the vec in storage. Okay, awesome. So function add member, boom. And so every function that's inside of a call block will always have a please shoot if you also know that. And I'm going to write it. But what are these things for? Interested to hear if anyone has anything to share there on this topic. But this is very basic. Like these are the types of patterns. It's like sort of like, I don't know, if you're just beginning with Rust, you're using the standard library to do like basic arithmetic, or you're using the option type, or even if you're a Python developer, you're going to be using like very common libraries to like NumPy, for instance, and there's like there's standard ways of using NumPy. That's just an example I can think of at the top of my head. In Substrate land, every call has an origin. Yeah, so we do that. We do that because every call needs to specify whether the call is going to be signed, unsigned, or not have any signature. And this is a very important concept in like blockchain world and Substrate world, because we need to ensure the provenance of this call and write logic according to whatever that provenance is, and also disallow certain calls that are tempted to be made based on a provenance check, like a who is this call being made from, and you can think of it as privileges. They're just ways to uh, like encapsulate privileges. So okay, I digress, but this function, it adds a member to the vec in storage. So we're going to say that the only argument from an end user perspective of this function is actually just an account ID. And we've added this tuple, right? So that is not correct, Sacha. It's not the only argument. We've got a member. We've got a let's get creative and say that this U8 is a it's actually like we're writing a palette where members of specific classes, like class of 2020 or whatever at a university we could think of. So class of and that's just a U32, and then we have the U8, which is like bytes. We can say like emoji, and that's just a byte. Cool. So we've got this partially written now, and always a callable function will return a dispatch result. Okay. Now we can actually, so hopefully that's just like very basic, like writing a callable function. And in the body of this, we're gonna just like, check. I'm just gonna write this. Check the origin. Then write to members storage. Cool. Sweet. So, oh yeah, I misspelled dispatch result. So what do we have that's here? Okay, and I think just to make this compile, we can yay, that's okay. We because this dispatch result expects, actually let's click into it just to double check. It expects the result either of a unit type or an error. We haven't really gone into errors. Maybe that's something we can dive into if you guys want, but I'm just keeping it basic around yeah. Oh, sorry. This we're in the membership palette. Cool. I'm gonna take a small water break. Do-do-do. Now, if we did remove dev mode, the thing is that we'd need to like add the weights and the index stuff, and I wonder if we can use we can just use, and I'm pretty sure we just use a bounded vec without actually switching to dev mode. Let me show you what I mean, and then we'll take it from there. So right now this is a palette that actually let's do something. Let's just extend this a little bit before we go into tweaking with dev mode stuff. I also want So I also want to have a block of code for helper functions. When we started this, like the setting of the scene of this episode was looking at different ways that things can be organized in your palette. And so I actually want a helper function to I'm gonna just add the doc. So I'm gonna add a helper function that writes members to storage, writes a new member. Oops. Okay. Oh, I don't want to do that. So So we just do. So remember when we were looking at, I don't know, what was it? Like, yeah, we did like spend a little bit of time on this NFTs palette. It has a lot of like fancy stuff and like this common functions thing. Oop. So common functions is very piece of common functionality, and essentially it's reusable code. And in our case, we're just going to showcase that, we want like a function to help a write to storage. And you'll see a lot of this pattern. Actually, we saw it in the lottery palette. Let's check that out. Inside of the lottery palette, there's this pattern of having a call and then just using a helper function to actually write things to storage. So in particular, you can keep an eye out for do do do. So the do functions are functions that will do all of the storage updates. So in this case, in this lottery palette, we've got this buy ticket call, and notice here, for those that are new to Substrate and all of this palette stuff, I'm trying to remove as much distraction potentially. But here you notice that there is this thing called call index and there's this thing called wait. In what we're writing right now, we don't actually have that. And we don't, and we have that luxury because we're using dev mode. And in dev mode, we don't need to specify call waits and call functions because we're in dev mode. That's kind of a nice thing about it. Just to show you guys, if I remove dev mode, then it's going to start yelling at me for multiple reasons, including that there's no bounded vec, that there's no index, that there's no call index, and that there's no wait. So that's not, yeah. Oh, there's just a mistake here. Actually, it's just unrelated to what I'm trying to show. What is it? Oh yeah, just to showcase what I wanted to do again. Yeah, so it's yelling about those things, and the very first thing is the wait. So back to here, I want to show this pattern of helper functions. We've got tick. We're gonna put back dev mode, and we're actually gonna ignore the need to put call index and wait, but we're gonna just write this helper function. So actually doesn't need to be public. So function do update members, and it will take the what we could do is, something like member tuple, like, I don't know, let member is, it'll be a tuple of, what did we say, member class of, and emoji. So yeah, T is coming. That's weird that it's thinking that, but that's okay. And then we can like do something like, so do update members will just take that as an argument. It'll take a ba-da-dum. It'll take a T account ID, U32 and U8. And it will return, what will it return? It'll return an option. What did this, for example, say? Like do by ticket. We should return. Of course, it'll return the same thing that the call function will return. Okay, so dispatch result, because it'll either error or return the unit type. Dispatch result. And now we can just write this function, and then we're going to actually write storage update here. Cool. Okay, it's weird that it's saying that dispatch result is on the scope, but we can just fix that by adding it explicitly. Oh yeah, because it's within this mod. So let's just put it at the top there. Cool, that should work. Cool. So yeah, what we're doing, deck, okay. And let's just see what's going on here. Yeah, it's not returning anything. So we want okay. There, I'll be happy now, right? Let's see. Do update members. What did I do wrong? To update members. It takes in this tuple. Or we can just say you know what, we can just super simplify it and just like call do update members with the exact. Let's just like keep it for now super simple. All right, and go back to this. Okay, cool. Yeah, it's basically saying the compiler's telling us that it's there's a bunch of unused things. Okay. Now back to kind of like this, the big picture here. We have this membership palette, and then what we want to do is update it, write members to storage, and we're showcasing like having this like impl block. So now let's just keep this kind of in mind, okay? And we'll just keep it in mind, but I want to actually step through what the thinking would be behind like abstracting things out into their own helper functions, and then we'll finish by abstracting them out into their own modules, and do a quick and dirty mock runtime. Oh, there's some questions I missed here. Cool. So let's say you have a custom balance type defined using the currency trade in your config and one create pallet, writing it this way because we have a multi-pallet create today. Well, what you could do is just have a mod here that then it's just defined once, the custom balance type defined once, and either of these palette can reuse. Hopefully that makes sense. Okay, so then there's maybe there's a follow-up to that. Is it a good practice to use the same type in all other crate pallets of your program, or is it better to redefine a custom balance type for each pallet? So the answer is that it's probably nicer if you're reusing the exact same type in these different pallets. Why would you need to rewrite it every time? So if that's your case, then you don't, put it in its own like types.rs file like this, and like types. This is something you see commonly, and that would be like, pub type balance right there. Oop. U28, but obviously like this could be, this could be any like other balance type. And then, we could say, like, exactly how this is done. I gave this example. I mean, we looked at this example when we looked at the recent core fellowship. No, what was it? Oh, a broker palette, right? It has this custom type thing. So types.rs, right? And essentially these are all the types that are used. And then, you could see that types, it's like they'll say mod types is being used there. So, we can do exactly the same thing. In fact, let's do that. Why don't we do that so that we don't need to specify this? Oh, the balance was in the dummy palette. Yep. Okay, cool. So we don't need to, so like if I take this away, but then I say pub mod types, or sorry, mod types. Yeah. And we need to make it, what's the syntax? We need to make that use create and that would work. So I don't know. Types and then yes. Right. Oh no, what am I doing? Dummy palette. But you get the idea, right? We have this like types thing that then will contain all of the types that are there. So yeah, my REST analyzer is just putting a lot of noise here. But yes, now we need to just like put our type back in here, just for the sake of keeping it succinct. Okay. Where were we? That hopefully answers that question. So it's not about good or bad practice. It really depends on your usability. And actually, so in this case, it wouldn't necessarily make much sense because we only really use it in this dummy palette. Okay, yeah, we're back. Cool. Yeah. So where yeah, I kind of want to like get to the end of this. And bounded vex. Okay, so we're going to just like finish writing this function. And I'm gonna ignore. Okay, so every time we're gonna want to update a storage in frame, we're gonna want to do some error handling. But what we won't be going into is like actually writing an actual error. But nonetheless, we've got this members storage value that stores a vec, and what I'm going to show right now is just jump right to it. When you're writing a frame palette, you will never actually use vectors in production because we need to know the maximum size of that vector, i.e. vectors need to be bound. Okay. So the trick is that we have this special type in Substrate called bounded vex, and a bounded vec, you can check the documentation for it, is this it's a data type that is available in frame support that allows you to use a vector, but it's a special type that specifies a maximum limit of that vec. And why is that useful is because in constraint blockchain resource land, we need to have a max number. Otherwise, your blocks can be filled. You have you have a harder time estimating the bloat of calculating. Um, I'm gonna keep it at it's important to know these things for for parachain protocol implementations, actually, but keeping it simple. Blah, blah, blah. So we're gonna use try append. We're gonna use this bounded vec, and okay. So if I go bounded vec will always take in 2 arguments. And the first argument will be the actual data type, and the second argument will be a maximum value. So the maximum value, usually it's actually something that's put in the configuration trait, but for now we're just gonna put in some const u32 that specifies, I think we might need to import this, that there's a maximum of 100 items that this vector can contain. What you would most commonly see is this config trait will have a configurable type that is something like type max members, and it will be like a get u32. Then we would just use max members here. So t max members over t, and then we've made this even more generic, right? Because then when we implement this pallet, we can actually just specify a value for max members. But for the sake of this, we're gonna ignore the configuration trait pattern and just go ahead and specify this. So cool. Now we have this bounded vec. What we want to do now is actually write this to storage. So what I'm going to do is write this members to storage, members t. So any storage write will have a bunch of checks. And in fact, let's write that check right now. Ensure signed. Cool. We always check that this origin is, well, not always, but in this case, we want to check that the entity that's adding this add member is a signed origin. And Frame has a neat way of exposing this ensure signed util that allows you to just write it in one line. We'll check what this origin is. So check that it's signed. We might also want to do other checks. Like, I don't know, maybe this member is part of another membership group, or maybe, maybe this member already exists and we don't want to add it. But this is just showing basic pattern. So then we have a member. Oh, that would, okay, we want to do new. We assume that it's a new member. Oh, that's why it was bugging out. So new member as this tuple, and yeah. So let's write that to storage. So we're gonna use try append because we're using a bounded vec, and if it exceeds that maximum value that we put here, that we specified here in storage, right? This is no different than saying, okay, there's a vec, except that here we're saying, okay, there's a vec, but with a maximum amount of entries that it can hold. So this try append is going to try and add a new member to this vec. And if it exceeds, it'll throw an error. So we do new member, because we already have it up there, which is nice. And we try to add new member, but then we've got to map an error, throw an error if it doesn't. So map error, and then some message like max members exceeded. Cool. So when we were doing, yeah, so hopefully that's pretty sound. Like we've got this storage value has a bounded vec, and we're using this try append method that will check it is able to add a new member. So this is a very, very important pattern in terms of using a bounded vector instead of just a simple vector. Cool. Pin on that. Yay. So hopefully that answered. Yeah. So yeah. So an unbounded vec could become an attack vector. Imagine if your call allows a user to add as many entries as possible. That's arguably fine, right? We've got some vec of U32s. It's not a lot of data ultimately. However, depending on the call, so there's kind of two answers to this question. The first is what I'm going over now. The second is parachain protocol stuff. But essentially, imagine that your user then can just like spam the chain with as many values inside of this vector. Well, you might suffer from some storage bloat over time. Whatever, you can maybe have a cleanup function of sorts. But the second piece is this thing called proof of validation function. So we can do a little bit of a detour here. Let's see. If we go to Stack Exchange, I'm sure there's some resources on this. So basically, I'm going to explain it to you, and then we can like look a little bit further. Every time a collator, so these nodes that are running these parachains, submits submits data that says, okay, this is everything that's happened on this chain. Relay chain, hi relay chain, can you go ahead and check it? Well, the relay chain needs to make sure that the that proof of validation, this data, which is called the proof of validation, isn't too big. It needs to calculate some max value of that. And so the bounded vec really comes into this concept of it taps into weights. It taps into the idea that we need to know this maximum amount any callable function and its storage can incur, such that we're in safe bounds, right? So that the relay chain receiving this proof of validation knows that it won't exceed some maximum amount of value. And using bounded vecs allows us to compute what those bounds are. It allows us to compute a sort of worst case of what those bounds are. If you have a vec that can have some super large number, or sort of if you have an unbounded vec, if you have a vec that does not have any bounds, it's really hard to calculate what that worst case would be. So we encourage the use of bounded vecs. In fact, it is like unseen to just use a vec unless there's like maybe some cleanup function logic or something like that. But even though that's not even relevant anymore, because to calculate this POV, we need to know what that worst case is. So proof of validation, maybe proof of validation. So what you want to research is this concept of max POV, like POV. Yeah, parachain block POV size. Okay, this is like maybe a good starting point. What does POV stand for? Well, POV stands for proof of validity. It's a specific concept in parachain protocols that allows validators on Polkadot to execute and verify blocks on the relay chain, which ultimately provides the shared security. Well, at a high level, the relay chain needs the following to execute the blocks, blah, blah, blah. And it needs the relevant state, which is read to complete these extrinsics. So that is what the POV is. It's this piece of information in the parachain protocol that requires what the state is from the parachain that's submitting to the relay chain, and then I don't know if Sean writes about this, captures the so the POV has a maximum limit for parachain blocks. This is kind of at the crux of it. On Polkadot, it's 5 megabytes, and so there's limits to how long it can take to put that information out, to gossip that information to the validators. And that's why there's this upper limit of 5 megabytes. And that is why that we need to know what the maximum, what the POV is, i.e. the relevant state to complete all of these extrinsics is at its worst case. And that's why we need to know that every single vector is bounded, and we need these bounds to calculate what that could be. And so we never want to have a POV that exceeds those limits, because then we risk actually bricking the blockchain. So yeah, I kind of like gave high level details about this stuff, but that's the keywords you want to be researching: this proof of validity, proof of validation, and this POV blob. And it pertains to, actually, maybe we can see bounded vec. So like the bounded vec concept really comes to, let's see if we have some update. Substrate bounded vec. I wonder if we have any actual docs on this in here. Bounded vec. Probably. No, I don't think there's some good documentation around the use of bounded vecs, but maybe that's something I can put to my Scratchpad. I think that would be actually really valuable info. Bounded vecs, how they relate to POV, and why they're crucial. They're crucial. They're really important. So cool. Going back to this, we've got like this impl block that's this helper function. I mean, I don't know if we really need to like go all the way here, but essentially you could imagine like this then does do, we can do like, instead of writing it this way, we've got like, do update members, and we actually we'd want to pass in like a we'd want to pass in something to this function, and then just do this. Write storage update here. Do update members, and then we're gonna like put in the tuple of account ID 32. And what was it? And try append. We can do like let member we have to like say member. No, we're just gonna do. What am I doing? I'm losing my steam here. So member account ID, class, and then whatever we said. We said emoji up, and then we can just do member as this tuple, member class emoji, and then we can just write member. Yeah, sweet. Patterns in frame. Do update members. Oh, let's make this. Let's see what the compiler tells us. I'm gonna just skip the whole. Let's fix it. We're in the business of fixing. Is that it? Oh no, yeah. Oh, we have the helper. Why don't we just put a helper function? Why is this one saying okay? No function associated name. Do update members. Cool. Oh yeah. We might be using it. Tab T. Yeah, because we want these to be public. So if we can do like, I don't know, an account ID. What's it saying? Yeah. Probably, yeah. Like, let's just take a peek at the pattern that we looked at in the lottery palette. What did we see? What did we see? Oh, did I even do that? No, probably not. I just incorrectly uncommented this block. Therefore, none of this was actually working. But now this works. The only thing is that it's still not happy about our use of self, but that's a little weird. Let's see what the compiler is telling us. Oh, Oh, yeah, I'm not this syntax is not correct. That's not right. We've got, um this isn't correct. Maybe we need to just make it more explicit. Like, you know what? We don't even need this. We we can just, right? We don't even need this, like, let new member. We can just do that. And let's see what the compiler tells us. Yeah, it's an item. Okay. It takes 3. Oh, yeah. So our function is just it's not actually just taking in one tuple, it's taking in the different individual types. So that's just also, I think, that's an artifact of not paying too much attention. So pay attention. Pay attention. Now that should do it. Okay, cool. It did. It actually compiled. Other warnings here? Yeah, just basically, okay, we don't need this. We can just do that. Cool. Let's get rid of some warnings. Okay, members. Yay. Okay, that's great. And then let's see if it's happy, and it is. Oh yeah, true. It says let. Yeah, we can do that. We can just do that. This is like Rust happy. Rust is happy now. Happiest. Yay. So then, yeah, cool. So super simple pattern of doing that. Now, what if we wanted to do like a similar? Should I just commit this? I'll just commit this for now, and we can kind of keep iterating on it. So dummy palette is there. Dummy palette again is really like it's copy paste literally of the other thing, but I'm just gonna commit this multi palette crate and do everything except the scratch pad. So add multi palette crate, and then just commit all that. Cool. And now in a different commit, what we can do is actually take it a step further and um follow the pattern that like, if we have like multiple helper functions, to put them in the you know what, that's I think that's probably that's probably something easy you can do. What I did want to finish with is like, okay, what if we had a mock runtime? And let's go ahead and do that. So I want to show that, for instance, you can have a testing playground that has both of these pallets inside of this source folder. So we're going to go ahead and do tests. Oop, why does it do that? Test. Oopsies. Okay, done. Tests. And then we can just go ahead and check the actually, I haven't checked the chat in a while. Let's see. Oh. I had the thing up for that was not intended. Sorry, guys. Yeah, so what does the super do? It actually, like, let's see if I take it out. I put it in there just as it was like a sanity check, but it would make it available to the other crates that this or the other modules, I believe. But if I take it out, it should still compile. I kind of did that as a precautionary piece. Right, cargo check. Yeah, it still works fine. The super makes it makes this available outside of this module. cool. Oh, and let me make sure not to do that. And now, yeah, let's persevere here. So got these pallets that are in their own modules, dummy pallet, membership pallet, and we're gonna put it like, because we have this from our last super basic example pallet, which, by the way, is just this lib.rs file, right? For those that are kind of maybe not for those that don't see the aha that I'm trying to show here, like typically you'll see it all in this lib.rs file. What we're doing is actually creating our own pallets inside of their own modules. And I'm just going to collapse this so we can see this super basic pallet test environment. In order to do a testing environment, you need to mock the runtime. Remember, at the very beginning of this episode, we looked at diagrams and we said, hey, this is the runtime and this is the client. Well, because we're not actually compiling anything to WASM at this very moment, and it would, be a really bad developer experience if every time we needed to compile to WASM to test our palette. Well, we're going to take advantage of creating our own little database locally, creating our own mock runtime environment, and this is what this is. So I'm gonna copy all of this up until here, up. I'm gonna just take it all, and then cool. So here instead, so I've copied what we had from the testing environment of super basic pilot, but the question the question would be, oh, and we would need to also add what is it, this, because it's going to tap into the testing module at membership, and then I can let you guys write tests for it if you're interested. Testing module, and it'll say, ooh, tests is not available. Well, let's make it available. Pub mod tests. Cool. Oh, unresolved import. That means we might need to import that. Totally fine. Let's see what the imports were here. Was it SPIO, SP runtime? Probably all of this stuff. Also, oh, yeah, that's happier now. But notice that, yeah. So notice that config is not. It's already telling us what we need to do. We don't need this balances. Let's get rid of that. So what we're looking at here is something super interesting, because this will also be a nice little segue for our next episode. We're looking at the mock runtime. So I'm going to get rid of everything we don't need that's not relevant. Can we just make this a unit type? Account data is in just a U64. Can we do that? Yeah. So I just changed that because I don't want to mess around with importing the balances palette. So I just want to do U64. We can probably just make the unit type. Can we do that? Let's see. Can we do that? Yeah, it might work. So in this mock runtime environment right now, all we have is the system palette, and we need the system palette to do a lot of things. And that's why it's a long list of types that the 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 configuration requires for this palette. And we'll need it to like write tests. But right now we're just going to focus on finishing this mock runtime environment for membership. So mod test. Why is this yelling at me? Oh, do I need to do super? Yeah. File not found. Create the model test. Okay, yeah, this is throwing me a little bit of a curveball, but then I'm going to keep it within the same file. I'm going to keep this mock runtime within the same file. So we're going to actually, no, I'm going to undo that so that we can see. And then I'm going to keep that. This will show you another pattern, I guess. So we can like actually just write the mock runtime in its own module within the same file, and then we can later on then do the sort of like abstracting it into its own module. But for now, we keep it like this. So in the tests, we've got a SP core. Let's see. Why is it not? Yeah, let's get rid of this test thing. It's going to be confusing. Keep it simple under membership. Remember I told you a tip is always just use cargo format when things get funky. And then we're good. Cool. Okay. Let's use SP core then. I don't know. Cargo add SP core. Oh yeah. True. I'm just gonna CD into the multi-pallet crate and then cargo add SP core. So now that should no longer be a thing. Awesome. One thing now we need to do is actually say, okay, this mock runtime is going to use these pallets. So I'm going to say use crate and be explicit and say it's going to say the mod called dummy pallet and then I'm going to say membership pallet and oh yeah, there's something wrong with there's something not happy. Yeah, we're going to get to that. We're going to get to that. I'm seeing if there's any questions. Yeah, Rust Analyzer is really heavy. My tip is that, like, if you're working on a small little crate, like kind of what we're doing, I mean, this workspace, it has like, this workspace has 3 different pallets, I guess. Yeah, it's like not crazy, but definitely is if you're running Rust Analyzer in the Polkadot SDK, like, look, I don't even have it running here. it's disabled for this workspace. It's really going to use up a lot of CPU. So that is something to bear in mind. Oh, yeah. Where were we? Yeah. We're gonna just say like, okay, use that crate. So we might like in this mock runtime we're gonna import our dummy pallet, and then I'm gonna say use. I'm gonna put that. Let's see all these. Oh yeah, this is like from before, but let's use re-export crate. That's essentially what we did. That's essentially what we did by bringing in the dummy pallet. And now we want to say use this. So this is why we needed use this membership. Yeah, we called it membership. And we're going to say as pallet membership. And then we want to use pallet membership. And that's all. Like, that should do it. Pallet membership, and then we want to say members. This is the name of the pallet, and pallet membership. Actually, we don't even need to use the other one. And then we're going to say dummy as pallet dummy. And then we need to, oh, we didn't do this here. We don't need this at all. So we want to say something like self as pallet dummy. Cool. Now we can, yeah, that would compile. And very last thing, because we're creating a mock runtime environment, we actually need to implement the we need to implement the configuration trait for this test struct. And really, like this struct, like we could just rename it to here. Let's just do that. Actually, it'll be clear. We're going to rename it to runtime because that's what this is really doing. It's same as if you would see it in the node template. It's making a it's using this construct runtime macro to compile all these pallets down into a runtime. Like again, this is a mock runtime, but you would see this pattern. So if I go like this, and I want to just replace them all so that they're clear. Yeah. Yep. Cool. Okay. We probably won't have time to write tests and stuff, but I think I'm just going to push till the end where we're now finally just going to implement the membership palette, and then Bob's your uncle. So this is where we can, so notice we only have the free and system implementation. It's here. And this is this macro weirdness, right? Construct runtime, like this is the least like this is the place where you will, like, oops, this is the place where you'll notice that that this is the least rusty part of the Substrate code base, where we use this construct runtime macro. And that's because we can like specify the palette name like this, and then write tests for it. We saw this previously, right? So we had this here, where I have example, and then I use that palette name to like call the functions of that palette. A lot of cool stuff happening under the hood. If you think back to where we noticed that like a palette is a struct, and then all the functions that are built in the call block are really just implementations of that struct. It's really just an implementation block of that struct. So I digress. Let's finish this. Cool. And then we finally, so we have frame system that's here. Now what we need to do is pallet dummy and pallet membership. So we'll say, so config, this is copy pasted, but we can just do this. So it's a config. Oh yeah, amazing. Rust analyzer is telling us. If you didn't have Rust analyzer in the back, I would recommend just actually do a cargo check, and it'll tell you what might be going wrong. Oh, funny. It's actually giving us little errors that are not going to help us right now if you go down that rabbit hole. And it's to do with this like externalities trait, but let's ignore that. But let's get this right here at least. Let's see if that error persists. But we want to do pallet dummy. This is the config of the pallet dummy for runtime, and then we want to do the config of the pallet membership for the runtime. And because we don't have anything in these configuration traits, remember I said that we could have done this max value. We could have put it here, and we should really, right? This is me just going through the basic pattern here. Well, if we did have like, let's just do it, max members get U32, and then we can just do T max members nope, we need another bracket. So now we just made it generic, and then like in our runtime implementation, this is now erroring out because we need this max members trait. And what I'll do is I'll just say type max members. I'll say type max members equals const U32, just how we had it before, to show you. And now we need to import const. Yeah, that's fine. Let's just do that. So we've made this module, this testing module, inside of this membership palette. And Blake 32 is not. Can I just put the unit type here to make things simple? Just to make things compile. No, I can't, huh? Let's see. Because it's a mock runtime, I need a type, yeah. Okay, so it'll just take a couple minutes. What we will do, the hashing is Blake, okay. Trait bound is not satisfied. The following types implement trait. SP runtime. I think it's being confused with some imports. It's definitely being confused by some imports. Well, then I think that this is a really, really good segue, because I'll show you the trick where, like right now, like let's see if there's any questions so far. Oh, sorry, I didn't mean to do that. Yeah, there's a comment on, yeah, like seeing testing of customized democracy palette. Um, Feel free to make an issue in the SDK Unwind repo with like a cool idea you'd like me to dive into, and we'll do it. Like that would be awesome. And yeah, with another palette to make the proposals. I've been really trying to keep it like super around patterns, but I think we're in a good place to have some content around like, okay, this is so. For actually had this idea, the idea of like, let's do a really dumbed down version of how the treasury works with members, and whereby specific members can make treasury proposals, and there's also a bounties palette where only specific members can approve bounties, and something that's really dumbed down, but it's an example of multiple palettes working together and bringing in these concepts that we're learning here. Now, I want to just shill this frame feature that that will take away these errors, I think. And so if I just fetch it from here, give me one sec. So this is this derive impl. And derive impl will allow me to, so I can just like remove this lookup and it'll provide me a default value for it. I can probably remove all of these things. And this is what I wanted to check out in the next episode, basically. I'm gonna bring on a core frame dev that will explain all of this. Ooh, that's messy. Let's see. It's still not happy with this. Interesting. Okay, so that made it even less happier. Wait, why is it? I'm gonna just remove. I'm gonna remove that and just like look at this fresh. Let's have a look. Mm-hmm. Let's see if there's some examples in like this test that we can lean on. Notice also this palette has its mock runtime and its own module itself, right? So up. Oh yeah, I could. Yeah, it needs to be explicit. That's probably why. Look, I'm gonna bring that in. SP runtime. Oh, it's a strange piece that I'm getting about this identity lookup, which is making it not happy, which is making my Rust compiler not happy. So just looking into it, what does it say? It's required by config lookup. No idea. Yeah. So the the cool thing is that we're gonna keep looking at. So now we've come to a place of like splitting up these palettes and stuff. In the next episodes, I really want to then get closer to like this mock runtime environment and start maybe putting together some cool functionality, some palettes that like we can do things. And like I guess this is me kind of like I want to I've done this little recap. We used dev mode in one of these palettes. We didn't. We actually use. We still have dev mode in this palette, but we actually did a bounded vec example here using max members as a config type. So this is this is max. allowed. Always nice to document your types and stuff. And yeah, what else did we do? Did the little pattern of having your helper here. And where we are now at is just having this mock runtime, which really I would like to I'd like to have it in its own module, which we'll check out in the next episode. So super thankful for everyone who tuned in. Very very stoked to keep going at this series and like learning with you guys. And I'm open for ideas that you might want to hack on, and we can like dive into it. For the next episode, we'll continue on some frame stuff, and we'll continue with like building your pallets and like looking at some cool features in frame. That's really what I'm trying to highlight, is like different ways of thinking about using frame, and building our own like governance like palette structure. I think is a really really cool idea. So I'm super eager to do that. Kizunobu, like if you want to actually just go ahead and make a PR at the SDK Unwind repo, or just write out an issue. Let's make it happen, and we can like dive into that on the next one. Very grateful for everyone who tuned in and participated. As usual, we will we'll be seeing you again soon next week. Always Wednesdays, 3 p.m. CEST. That's like 9 a.m. if you're on the east coast of the States, etc., etc. With that said, I wish everyone a fantastic day, and we'll see you next week. Cheers.